Hello everyone, I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in the air compressor lecture series, now we are going to discuss about the rotary compressors, especially in the roots blower rotary compressors. So in this way, I am going to discuss introduction about the rotary compressor, key components of rotary compressor such as labeled rotors, sealed casing, timing gears as well as inlet and the outlet ports and compressor cycles and performance characteristics of rotary compressors and real world applications such as automotive superchargers, wastewater aeration and pneumatic conveying and aquaculture aerations. Finally, we are going to discuss about the design thinking optimization. So let us discuss the introduction about the rotary compressors. Rotary compressors are a class of positive displacement machine that trap a fixed amount of the gas and force it into the small volume. So it increases the pressures. They are vital in various industrial applications due to their efficiency as well as the continuous flow. Like positive displacement, it fixed volume of gas compressed and continuous flow it has a smooth as well as the pulsation free operation and industrial applications used across the diverse sectors. So the roots blower principles of operation, let us discuss. The roots blower is simply an effective rotary compressor, one type of rotary compressor. It is distinguished by its two counter rotating lobed rotors, typically figure 8 shaped. So within the casing, it operates on a positive displacement principle, drawing in fluid and pushing it through the throat without internal compression. This is the principle of roots blower. So some of the key concepts of and how the roots blower work, rotors, that is called lobes. It is typically 2 or 3 lobes meshing precisely without touching. And the second one is casing. It encloses the rotors and providing a sealed chamber to the compressions and timing gears. It synchronizes the rotor rotations as well as the maintaining the clearance. The clearance volume is nothing but it is the one of the key terminology about the uh, air compressors is nothing but the volumes available after the piston is in the TDC position, that is dop dead center positions. So the timing gear synchronizes the rotor rotation as well as the maintaining the clearance volume. Finally, the inlet and outlet ports where through the inlet port the air enters and compressed air exits through the outlet ports. These are the key components of the roots blower. So coming to the compression cycles, there are 3 stages. First stage is intake, second stage is transport, and third stage is discharge. So the root blower cycle involves the distinct stages, as I already said, the intake, transport, and discharge. It is crucial to understand that external compressor occurs when the discharged air needs the higher pressure in the outlet, not through the internal volume reduction. So in the intake stage, rotors rotates, creating the low pressure area and drawing gas into the intake port. And another stage, second port is a transport port. Gas is trapped between the rotor lobes and the casing. It transported to the discharge side. Final stage is discharge. Is gas is escaped to the discharge port, encountering the higher and the compressing externally. These are the stages, and this is the some of the performance characteristics like pressure ratio as well as the volumetric efficiency. The volumetric efficiency decreases with increases the pressure ratio due to the internal leakage. So these are the real world applications like superchargers, wastewater aeration and pneumatic conveying. In superchargers, it increases power in automotive applications. In wastewater aeration, it provides the air for biological process in treatment plants. In pneumatic conveying, it transports the bulk materials in the industrial settings. So coming to the design thinking stages, there are 2 stages I am going to discuss. One is the empathize stage, another one is the define stage. By applying the design thinking to the compressor designs, it helps to create the user-centered solutions. And empathize involves understanding the need of engineers as well as the operators, while define clearly articulates the problem to be solved. In the empathize stage, it absorbs and understands the user challenges like noise, efficiency as well as the maintenance. In define stage, it clearly articulates the core problems and how to reduce the energy consumption in the aeration system by 20%. So this is the design thinking involved in the air compressor system.